We're thinking that's one up. Alright, wonderful. So that is up. And 3, 2, 1. Alright. Let's see. So that is up. That is all set. Alright, so I basically have one task that I need to get done, which is finishing or rewriting the OBJ file parser for compensation social. And the issue with that is it means I need to implement the OBJ spec in a performant manner because our old version takes 23 milliseconds to parse a OBJ file, and that's with no additional load. So, and that's on PC. That's not even just on. It's not even on Quest. So performance is a major issue. Memory is not as much of an issue, hence over allocating array. So we're kind of trading memory for speed in this case because we're allocating significantly more memory than we need to, but it's worth it because it saves on performance. So I have blocked out the basics, and we're just going to run basically a dry run benchmark on this to see how it performs comparatively. So, okay, external 50 milliseconds, native 5. It's interesting, I wouldn't expect it to take 5 milliseconds just to iterate over that file. I wonder how much of that is actually just the I/O, actually, not even the system itself, because this basically does nothing. This whole thing is just comments. So it's basically allocate some memory, read the file, do nothing, because everything else is just empty. So I'm thinking that might actually just be the file call. So let me actually benchmark that real quick, so that way I can be sure of that. So bench. Hello Hydra, I have not seen you on here before. So let's do IO file API benchmarking.end IO file API, and then we can just do file.read all lines path, and I need to include that. So this just gives us a baseline for how long the actual file operation takes, because my guess is that's most of the parsing time on the native implementation. So technically we could, or actually I just realized I forgot to log that. So double mess or double file equals, and then debug dot log file read time file mx. So that just gives us a baseline, so that way we know what the actual algorithm costs compared to, or what the actual algorithm costs? Yeah, costs. Compared to just the basically constant file IO call, which goes straight to the OS. That's something I can't control. But it's also occurred to me it might be faster to parse this by manually parsing new lines, because we have read-only span, which I don't think file uses. I mean, it's in the .NET core, so it probably does, but we'll see. So file read time was 1 millisecond, native was 5 milliseconds, so that's still 4 milliseconds unaccounted for, which is obscene. I wonder how much of that is just allocation time. Let me actually profile that, because now I need to know, so that way I can optimize this. So we'll do rent window analysis profiler. Oh wait, I can't do that without setting it to edit mode. And then I can just do record, run. Okay, so there's a big spike there, which is to be expected. So let's see, 76 milliseconds total, because it's running all in one frame. 3.1 megabytes. Okay, so let's do self. Okay, so this is the big one, clearly. So gc.collect. So it's these two gc calls, I think, that are most of that time. But then let's see. This is all gc alloc. Strange that it's allocating that much. Wow. Do we actually need this type of call stacks? Jeez, this is a lot of allocations. Okay, so let's just do, what's the method called again? Parse. Parse. Wonderful. So it's just not even on there. That's weird. So most of this is actually a full ton of GC allocations, but why is it calling that many GC allocations? There's no reason for it to be doing that. Let's see, there's so many GC allocations. Jeez. This is like thousands of GC allocations. Why on earth are there so many GC allocations? Okay, so that's weird, actually. That's like thousands of GC allocations. Okay, so that's good to know. Let's see. Oh, the wonders of the Unity profiler, where it has a tendency to make no sense. I'll set this back to play mode and close the tab. So that isn't giving you much information then. So I'm not sure it would take that much time then. I'm guessing it's all GC allocations then, because that would make the most sense. But then that would mean that it would be a one-time cost incurred. Right, so what we can do is so let's actually start on the actual parsing, and we'll see how performance evolves from there. So let's go into OBJ parser. So first off, we'll parse vertices. So that'll be this right here. So this just parses vertices. So we need a way to read a number from here. If I actually pull up this spec, I'll just move that to a new window. So this is the OBJ spec on Wikipedia. So comments are already handled. That's just a switch case that falls back. And so then no, I'll actually just do a default return, because anything that doesn't have normal behavior can just kind of be ignored. So that's nice and simple. And then, or actually wait, no, that should be at the bottom, because otherwise that's just going to ignore all of this. So that can go there. IOPA. So let me rerun that real quick and see if that was part of it. So in case you hadn't figured out from the name, I'm rewriting the CVR OBJ parser to support, to basically just be faster. Because right now the external implementation that I totally didn't copy is 32 milliseconds. I think it averages about 22 when the file is cached in memory. So native, oh wow, native jumped down to 1 millisecond, not including the file IO call, which is interesting actually. And then, yeah, so native is consistently better, but that's because we're not doing any actual parsing yet. So what we're working on there is the actual specification, because before we were just basically handling comments and nothing else. So right here we have the spec. So it has vertices, texture coordinates, normals, and faces. And then what we don't support is parameter space vertices, which is basically curves, and line elements, which we also don't support because there's no real reason to support lines. If we supported lines, it would have to be its own object, which would be like a line renderer, which I really don't want to implement right now because I have like 4 days left to do everything. If anything, I'm probably wasting some time doing this with the parser. I could just put it up, stick it on another thread, and be done with it, but that feels kind of wasteful because then you're still just waiting and waiting for your object to import, which is a pain. So what we can do is, so we know we're already at position 2 at least, or 3 actually. Hello Nub. We are writing a parser for a wavefront OBJ file, which is a file format for storing mesh information. So you could export it from something like Blender and then import it into CVR, which is useful for people who want to make things on their computer and then import it in-game. But then this parser is in-game, so we can also do it on standalone. So if you, say, have a computer that can't run VR, you could still model something and stick it on your Quest and then import it from your Quest, because everything supports standalone on CVR. So let's see, what we can do is, there's also the issue of basically some OBJ exporters, some OBJ specs honestly, I'm not surprised you expected that, but basically some OBJ exporters, or some OBJ implementations I should say, they will put double spaces instead of single spaces, so we need to account for that. So what I'm thinking is we basically just do a I really want to write this like a parser, but if I write it like a parser, it's going to be slower than just reading the file. So I think the way to do this is have basically another span that's read-only, and we just take a span off of this span, and we basically just give it from right here until the end of the line, and then we iterate until we hit something that isn't a space, and then we make that our start point, and we iterate until we hit another thing that is a space or a new line, and then we make that our endpoint. We grab the string between those 2 points, and then we parse it to an integer, or a double, as it were, in this case. I think that's probably the way to do it. That sounds like it won't impact performance too badly, I don't think. So I think we'll do that. So, what we can do is we can have thanks nub. So what we can do is we can do private private double read double. And actually I'll make that nullable. So if we immediately hit a new line or the end of the string slice, then we'll return null. And we're gonna need a read-only span car line slice, just slice. And what we can do is we can set int start, int end, actually I can streamline that. Wonderful. So those are our 2 positions basically. And then what we can do is, I'd like to avoid doing substring calls if I can, because I think read-only span has a way to parse. Actually, that makes me interested. So double.parse, what does this support? Read-only span car, wonderful. So if we just do another slice within that span, then we're golden. So what we can do, and actually I think this should be a tuple, and we can have an int, which is our end, and that is just where the number ends. So we can return, so what we can do is we can do return int.parse slice.slice start end start end, and then wrap this in a tuple, and we can return end. Wonderful. So that's nice and concise. I think that's fairly self-explanatory. When you're reading it, I'll actually wrap these lines, that way it's a little bit clearer what's going on. So, okay, so now we just need to figure out where the start and end are, which from there is pretty simple. So, what we can do is, how do I want to do this? While start less than slice.length, start plus think we can just do if start or if slice start less than 9 and or less than or equal to 9 and slice start greater than or equal to 0, break. And then otherwise we can do start plus. And then if start equals slice.length, we can do return null and so I think that's the way we can go about that. And then actually we want this to be -1 because otherwise we'll have an index out of range. So that reads a double. And then if we encounter a number, we stop and we set the start to that position. Then we need to do the same but for the end. So we read until it's something other than a number. So what we can do there is end equals start, and then while start or while end less than slice.length if slice end greater than or equal to 9 or slice and less than or equal to 0, then we can do break. Otherwise, and plus plus. So, okay. And then that gives us our endpoint. And we know that will be within bounds because if it's equal to the slice length, then we, yeah. So then, I'll actually start minus minus there. And then, okay. This is getting a little confusing, but anything to do with parsing always is. So then, that should be our start and end points defined. I want to say. So, what we can do from there is alright. So now that we have read double, we're also going to want read int. And then that's basically exactly the same thing. And, or actually, and slice and not equal to dot. So that's pretty simple. And then int is just the same thing, but it doesn't support dots. That's it. That should not be int.parse, that should be double.parse. And then we can just do read int. And then we can do int. Great. So that gives us our value and our endpoint, and then we can just keep reading from there. So yeah, those are two useful utilities. So now what we can do is, first off, we're going to, or actually no, we need to read That's fine. This is a bit confusing. I'm not good at writing anything to do with parsing. Because it's occurred to me that that start will be negative if it's the first character. Or no, it won't. But it will, because if we start with that character, then it won't get incremented, but it will get decremented, so it will be -1, which will throw an index out of range when we try to do the subject. Okay, so I'm not sure how to fix that then. I mean, I could always just do a check, and if it's I almost feel like this could be better accomplished with a for loop instead of a while loop. I think that's probably the best way to go about that. So what I'll do is I'll just delete that, and we'll do, and actually I can delete this whole function because it's just a copy. And then I can do for, and then I can do start, delete that, and then slice.length. Okay, so that's already cleaner. And then what we can do is if slice start equals less than or equal to 9, and slice start greater than or equal to 0, then break. And then that's all. That's the whole thing. So I'll actually remove these brackets because that's just a one-liner. And then we can do and equals start and do the same thing. So for and slice.length, and we can remove the int because it's already declared. If slice and less than or equal to greater than or equal to 9, or slice and less than or equal to 0, and slice and not equal to dot, break. So that's much simpler. Well, not really, but it makes more sense to me. So what we can do from there is duplicate this function, call it read int, and remove the ability for decimal points. And just like that, that's the int parse function. So that makes things fairly simple, I want to say, because that gives us the end of the number, it gives us the number itself, and it does that in a fairly quick manner. It's quick enough that I could think of. And everything is stack allocated. The slice is a slice, so that's not going to be an issue. We're not allocating more memory on the heap. So this should be a pretty quick function. What I'll do actually is I'll set this to be aggressively inlined, just for tiny performance gain, because I'm a bit obsessive about that. So that should speed things up very slightly, albeit at the cost of a higher package size. But that'll be negligible, considering it's already like 500 megs. So now what we can do is, I'm going to set the and in so we actually need to exit out of this early if the start is equal to the slice length, because otherwise we're going to get index out of range and it's going to fail to parse, and there's going to be a lot of nasty stuff. So what we can do is, if start plus 1 equals slice dot length, return null zero, and then we can do the same way down here. Wonderful. So that's just a bit of basically safety, because otherwise things would get messed up. So what we can do from there is we need to read the X, Y, and Z, and those are all required. So if those aren't in place, we basically can just throw out that vertex. Or I think we should probably set it into an error state and then keep reading, so that way we know all the errors. Or we could just throw an exception. That could honestly work too. I think what we'll do is in the iParser, we can add a public bool is error, and then we can do public bool is error, and then we can do private bool error equals false. And then what we can do is have an error function. So I should really stop mixing my types. Let me actually fold this all. So then we can do private void error, and we can do or error at int line, and we can do error equals true, and we can actually do a string message debug.log error obj parse failed at line \n, and then escape quotes message. Wonderful. So that just gives us the ability to error out, and then it won't proceed with trying to load that into a mesh and all that. So we can do, I almost wonder if we should convert this into parse and mesh, or parse and get mesh, and make them two separate functions. That would probably make more sense, honestly. So we can do public void parse public mesh get result. Is this a struct? No, it's a class. Good. So we can make that null, and then we can just do public void get result and private mesh result equals null, and then we can just do result equals. And then from there we can just do if error return, and then we can just do void and result. Wonderful. So that don't see the error in that. It's a mesh, not void. Don't know why I thought it was a void. Alright, there we go. So that is the new API for that. So that makes more sense. And then we can do process line. There's going to be a lot of unfolding things. So now it's just a matter of, well, parsing. So what we can do is double null or var result and x res x and x equals read double line dot slice 2. So that's as close as we can get. That's as close as we can cut it, knowing that it's going to parse okay. Technically, we could go a character further, but that would only work on non-standard implementations, so not ideal. So that gives us our result, and then we can do if res x equals null, we can error at we don't have a line number. That is a minor problem, so what I'll do is private int line, and then I'll just do line plus plus because we have a position there anyway, so might as well use it. And so we have a free expression there that we can use, and then that gives us the ability to, well, that should be 1, and then we can do error at line expected int double got null. Oh. There we go. So that gives us our line number, it gives us our error, and then from there we can do var result result x. No, I can't do that. I can't put spaces in identifiers. We don't really need that. So then from there we can do float x equals float res x, because we need to do that lower precision conversion to make it a vector 3, because you can't make vector 3 doubles, which is irritating considering Unity is not ideal with floating point precision, but oh well. And then we can do so now we can do var res y and y equals read double line dot slice and x. So that gives us our y, and then we can do if res y equals null error at line come expected double y y but got EOL, and then we can do float y equals float res y, and then we can do the same thing over again. So var res x res z and z equals read double line dot slice and y if and y equals null error at line number expected double z but got EOL. I don't normally type this slow. And then line num, and then we can do res z, and then we can do var or float z equals float and z or res z, and then we can do vector 3, or no, actually we don't need to stack allocate that, I don't think. Probably a good idea. So vector 3 v equals new vector 3 x y z, and then we can just do positions, or no, in case it's vertices dot add v. Wonderful. So that parses vertices, I want to say. I believe that's how that works. Yep, so geometric vertices, and then we just stop. We don't even bother parsing w. W just gets ignored. So, because we don't support vector 4s in vertices, because there's no reason for us to have 4-dimensional objects. This isn't a non-Euclidean game engine. So, we just don't. And Unity only supports vector 3s and meshes anyway, so we're basically working within the constraints of the engine here. So, I'd say that's pretty robust. Let's actually see how that impacted performance now. Because this has, I want to say, like a couple of thousand vertices. Oh, wonderful. An error. Right. So we need to do, let's see, what was it? Network debugging tools, and we need to fix that. So, native.parsePath, debug.assert, native. We actually don't need to get the value, so we can just do native. Let's not deallocate it just yet. So we can dispose of that, and then what we need to do is we need to we can do native debug.assert native dot is error, and we want to invert that. So that should be true, and then we want to do native equals null. So that just deallocates native at a certain point once the garbage collector kicks in. So let's see if that works. That's all the issues I can think of on vertices, and we'll see how that actually goes. I don't think this has less than 256 vertices, so we will actually see some allocation, which is a good test. So let's see. Input string is not in the correct format. Okay, so that's interesting actually. I didn't expect the error. So already you can see the inlining because the exception is thrown from here, not from here. Not in a correct format. Okay. So let's open that up in Notepad. I think I can open up this in Notepad. Let's see. So we can go Documents, All Files, test.obj. This is going to take a minute. Okay, cool. So, off to a great start. We have some things that aren't in the spec, which are Oh, I don't think that's in the spec, actually. I want to say that's not in the spec. Okay, it is. In materials, we don't support custom materials in OBJs, so that can basically be ignored, I want to say. So again, that goes back to the default to ignore as opposed to default to error, because I'm not dealing with that, just no. So then we have a whole bunch of feet. So I actually want to see what this outputs. So let's do debug.log line.slice2, and we'll see what that outputs. Oh, is it not like that? Ah, okay, so I need to convert it to a string. Wonderful. So we got that. Let's rerun this test, because now I need to know why that fails. I'm assuming it's a bug in the parsing code, because this is exported by Blender. It's not going to be non-standard. Okay, I don't see an issue with that. I want to say it's probably, the start is probably too high, is my guess. So it probably starts with a point, not a. So let's do debug.log start. Or actually, let's do debug.log slice.slice start. And .toString. So that's that. We're still at a pretty high performance gain, but that's for obvious reasons because we're not actually doing all the parsing yet. So I fail to see the issue. Are we trying to parse an int? No. I'm kind of confused then. Let's see. Debug.log slice.slice start end dot to string. I'm guessing maybe it ends with a point or something, or where my parsing code gets confused. That would be my guess. Well, that's unexpected. It just immediately fails. It just completely switches to start, and then it doesn't continue. That's weird. Let me, not what I meant to do in Visual Studio. So let's actually debug.log slice end, and I want to see what that outputs. These debug logs are temporary, by the way. They're going to get removed for obvious performance reasons. But right now I just need to figure out what's going wrong. I'm willing to bet this is an issue on my end, as most things are. 0. Wonderful. Well, why is that 0? Are we assigning those in the wrong order? No. No, that's how it should be. So it's logging 0, then it's logging nothing. Where's this? This is... Less than... That should be exclusive, not inclusive, because otherwise it's going to fail. That would explain it. I'm willing to bet that was our issue. So I'll remove those debug logs and try it again. Usually making things the right way actually helps. It's incredible. I'll actually do that here too. Because start should be inclusive because we're looking for something inside a range, but end should be exclusive because we're looking for something outside of a range. So if it isn't a valid number, or it isn't a valid oh wonderful, it appears I've managed to crash Unity. Or it's just really, really slow. It could just be really, really slow. Although it would appear I've managed to crash Unity. Nope, it's just really slow. Jeez. Okay, so I got 400 vertices in, and then it just stopped. That's lovely. Negative. It doesn't support negative values. I forgot to add negative support, so as soon as it encountered a negative vertex, it just didn't. It just ceased to exist. So now I'm curious, what's this? What do you want? It doesn't do anything there, buddy. There's not a line code there. But anyway, so it should support. It should in fact support negatives. Or slice start equals negative. Wow. I don't know how I just casually forgot that signed numbers exist, but I guess that's just kind of what happens. So then I'm curious why it's taking that long. I'm willing to bet it's actually the I/O that's taking a long time, not the vertex parsing itself. So I'll remove that, and we'll make sure that that runs, because I'm willing to bet that will be several times faster. Because, you know, I/O is one of the slowest things you can do. So we've already lost a millisecond at a minimum to I/O. So I want to try and keep it as close as possible to that millisecond. So max like 2 or 3 milliseconds. Well, that's already significantly more. Still significantly more. Alright, 15 seconds. Okay, there we go. Ah, I see, I was doing more I/O. That would explain it. So another format exception, that's weird. Where are we debug logging? Where is the log? Oh, I see, there it is. And then we're doing something up here. So something here shouldn't be negative. Or rather, it's just showing a negative, and that's it. It almost makes me wonder if this OBJ is actually has an issue with it, but I strongly doubt it because it's worked before. Okay. So it threw an exception again, but 48 milliseconds. So, okay, input string was not in correct format. So, what I'll actually do is double val equals double dot parse slice start dot dot end, and then I'll just wrap this in a try. So that's not how I want things formatted. Thank you for the effort, Visual Studio, but that is really not how I want things formatted. So I'll do debug.log exception x. And we only need that in double for now. So then I also want to do debug.log so we'll do that for now. And then we can do double.log or debug.log slice start dot dot end, and then to string. So that gives us the chance to check our work. So I'm guessing it's something to do with negative numbers, because it really seems like it doesn't like that negative numbers. I'm not seeing any logic errors. Most of this is going to be pretty simple because all the rest of it is basically just using those functions, the parse double and parse int. But once we get the core down, it's pretty simple. It's just before that it's kind of a pain. Okay, so it actually got through. I don't know if you know this, but it's supposed to be logging how long it took. Okay, so I see we're getting an error. I don't think that should be throwing an exception. I think that should be logging an error. But so global object must have a value. So we do actually need to skip this whole thing. So we need to do that break. Because I do want to just stop processing as soon as, or stop processing the line as soon as it hits an error. So we'll do just break. Wonderful. So that should fix that. Obviously this isn't how we actually want to do things. We want to just, we don't want to throw away any errors. This is all just for debugging purposes because obviously there's a lot of bugs. Already off to a bad start. Okay, so 374 errors. Wow, that's impressive. I wonder how long it actually took. 2055 milliseconds. 2 seconds. 2 whole seconds. I mean, it worked because I caught all the errors, but it chugged through it. So let's actually go to one of these lines. So let's go to 747. What's here? $747. Where are we? Negative number. Okay, so it just hates negative numbers. Okay, let's see. I think it's hitting that. That's weird, because I see. Slice and not equal to negative. So that counts. So that will still error out if it encounters a negative sign at the end of a input, but that's really stupid. You'd have to be intentionally fudging your OBJ, and at that point, like, why? Unless it's for testing purposes, there's no reason to do that. So let's run this. Boom. Alright. Look at that! So that's a significant performance increase. So that's only vertices, but that's still a significant performance increase. It's not what I'd like, but it's something. So let's get that in cache and try again. Look at that. 2 milliseconds. 2. Compared to 29 and 31. How's that for an improvement? So, obviously it's not done, but I think it's pretty safe to say this will be faster. So, let me remove that debug code, because that will also speed things up, and we'll go from there. So, double.parse slice start.end, because honestly, if we throw errors, it's fine. I can deal with that. It's when the errors are basically intrinsic. So logic errors are logic errors are the issue. If the file is invalid and we throw an exception, that makes sense. It should. It's when it throws an exception because of my code that it's a problem, because then you can't parse valid OBJs. So let me slice. So now I actually need to do and slice and not equal to negative. So like I said, that puts a hole in our parsing support. So if you have a negative sign at the end of a value for some reason, it will eat it up and then it will fail to parse it to a value, which is fine. I can deal with that because that would only happen if you're intentionally doing it, which at that point it's not going to work anyway, so there's no point, there's no reason. So let's get that in cache and do it again. 2 milliseconds on the dot. So that's what? That's a 14 times increase in speed. Like I said, it's not storing, it's not doing anything other than parsing positions, but it's still significant. Like, huge. So, if we can maintain that 2 milliseconds time, I would be, that's ideal. So, max I want to try and get, max I'd take is like 4 milliseconds, I think. But, I think we want to try and keep it at that 2 milliseconds. Actually, I think we should adjust this benchmark. I don't think this benchmark should support, I don't think this should include file I/O because that's really not in the scope of this test. So what I'll do is I will actually parse it twice. So I'll do once just normally, and I'll do once not including file I/O, and that will show the actual speed of it. So we'll see. It's not, it's kind of hacky, but oh well. So what we'll do is we'll do public void parse, and then we'll do string array lines. So parsers should support both direct input and, or no, that doesn't make sense. It's occurred to me that if this is going to be a universal format, we're going to have to support binary file formats, which don't support lines, obviously, because that wouldn't make sense. So that shouldn't be available, but oh well. So there we go. So this is our benchmarking code. So now we just need to do the rest of our parser. So that's 1, 2, 3. And since our read double and read int implementation is already done, we can just continue. So then I think since we don't support curves, we can just ignore them. So we can do default break, and we don't support lines, so we can just erase that because the default is already to return. So we only support vertex position, vertex UVs, vertex normal, and face collections. I think it's a pretty acceptable subtraction, considering I think we already didn't support curves or additional vertex information. But tell me if I'm wrong. So we're already performing faster than the external implementation, that's a given. But we need to maintain that edge. So I know that it's already taking at least 0.5 milliseconds, which may not seem like much, but considering that this needs to be run in a single frame, it is. So I'd say we could do better, but not right now. So I'd almost say it's easier to just do a try catch on the outside of this and just throw an error if something happens, because I think what we'll do is we'll do in the editor, we'll do an error if we're at runtime, we just pretend it didn't happen and hope for the best, right? And also I don't think we need these extra variables. This is a waste of stack space, so we can just delete, 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 and then we can do float, and that's just a direct unsafe cast. And then we can also do res x, res y, res z, and that's that. So now we just need to if-def Unity editor on these error checks, and that only does error checks if we're in the editor. Otherwise, we can just throw an exception and catch it, because that's more performant, and that's what I'm going for. So we can do if Unity editor and safety checks, and then end if, and now we can just Alt-Shift and copy these down. And then what I'll do is I'll leave safety checks undefined. Actually, I'll just do not disable. So that will just throw an exception if anything goes wrong, which is unsafe, but it's faster because we're not doing that comparison to null, which is good. So I think that will improve performance slightly. So what we can do then is at the top of this process line, we'll just do define disable safety checks. Okay, cool. So I guess we have to do it up here. Bit nitpicky, but okay. So that defines disable safety checks, so the safety checks will not be run, and then, or they won't even be compiled actually, but so now the safety checks won't be run, which should improve our performance very, very slightly, because that if clause is still a performance overhead, because comparisons to null are not exactly cheap. So let's do that again. File read time 0 milliseconds. So that shows that the cache is an important part. So file read time 0 milliseconds, and then parse with native in 2 milliseconds. So that's all just algorithm. None of that is safety checks. None of that is file time. That's just flat out algorithm. So that's what we're trying to optimize, is that 2 milliseconds. So I think first things first, I'll comment that out because we do want safety checks normally in the editor. So now safety checks will be enabled, but only when we are in the editor. If we're not in the editor, they will be basically erased from the code. They just cease to exist. Obviously, there's still safety checks inside these casts, but that's something I can't remove. Technically, I could do that with unsafe code, but honestly, that just ruins the point of having a cast there, because otherwise, like, we're not going to throw an exception if something goes wrong. So basically, if something goes wrong, it's going to go very, very wrong. So now from there, I think we can... Next, I think we want to do texture coordinates, but this is more difficult because it has two optional ones. So W can just always be ignored, just like with these W in vertex positions. We can just ignore that. It's a vector 2 in Unity, so we're not losing any data. It's just going to get lost in transmission anyway. But that optional for V means we need to use the default. So what's the actual standard default? So default to 0. Okay, that's easy. So that can just basically be a I'm trying to think. That can basically just be we can just compare it to null. If it's null, we use 0 instead. So that's doable. So now let's see. So from here, this is pretty simple actually. So we'll do var res u and u equals read double line.slice 2. And then we can do a safety check, so if Unity editor and not disable safety checks. Disable safety checks and if, and then from there we can just do if res u equals null. Why are you complaining? There's an end if here and a break. Why are you complaining? This shouldn't be falling through. Ah, I see. So it thinks this is part of a break. So we need to do error at line num. And actually, we need to do in V, because otherwise we don't know what kind of statement this is. So in V, in V. So that just makes things a bit clearer when you're reading it. In debug logs, which I will have to do most likely. So now we can do expected double V in, or expected double U in VT, but got EOL. Wonderful. So now we can just do the same thing, but we don't need a null check. The null check is going to be non-conditional, because if it's null, then we set it to 0. Honestly, we probably could have just had a thing that sets it to null if it fails, but that's besides the point. So, or not null, but 0. What we can do here is vector 2 v equals new vector 2 float res u, and then v. So v is going to be assigned manually, and then we can just do uvs dot add v, and then we can do float v equals, actually we still need to read this, so we can do res v and v equals read double line dot slice and u, and then we can do float v equals res v equals null 0 res v. So that gives us a safe default. And we do need to cast that, so float. What do you mean it's already defined in this? Oh. I'll just call that Vec, because that makes more sense anyway. So Vec. And actually I'll rename it up here just for consistency's sake. So this should be all set. So let's run another benchmark, and we'll see how that goes. So we can do that and that. Oh, and we got a parse error. Wonderful. So we are actually, I think, one character too short, because this is 2 characters, not 3. Or 2 characters, not 1. So we do need to bump it forward by 1. So yeah, I want to say that's the issue. That's the most obvious issue, that is. So let's run that. Oh, mesh.uv is out of bounds. The supplied array needs to be the same size as the mesh.vertices array. So about that, no. So parse with external in 122 milliseconds, parse with native in 33, so still significantly faster. File read time 9 milliseconds, wow. So let's see, so parse with native in 5 and 3. So still pretty good. Not good, or it's not ideal, but it's good. So let's see where this is. I'm guessing it's in the assignment to creating the mesh. But it should be the same size. I don't see why it wouldn't be. So let's do real quick. Get result. No, needs to be in here. And then if vertices.length not equal to uv.length debug.log error vert vertices.length uv.length. So those should be the same length, and I'm curious as to why it didn't throw an error before. Because before we were just assigning it nothing. Just a nice long array of absolutely nothing. So, does this still throw an error? So, 744, 816. I'm curious as to why that is, because it should have a UV for every single vertex, not multiple. So let's see. So VT 2, 2, 2, 2, 2, 2, 2, 2, 2, and a whole lot of that. And that's just a bunch of 0. I'm curious as to why that happens, because that should just be the same number. I don't see why it wouldn't be. Because that doesn't make sense. It's weird, because that should be the same number. But it didn't do that when it was 0. When the length was just 0, it ignored it. And didn't throw an error. So I'm guessing there's something wrong with the UV implementation. So let's see, are we pushing multiple times? That's my first question, is are we pushing multiple times? So let's see. Process line, T, uv.addVec. that doesn't make sense. Because that should be, yeah, that should be the same number. I don't see why it wouldn't be. The only thing I could think of that would cause that is Blender feeding in more. Is there something else that starts with VT? So, I'll open this up actually in Visual Studio. So, open file, and then we'll do documents and test.obj. And then I'll do a regex search vt.that. 816. So that is the right number. I'm curious then why that happens. I think it's dot. Okay. So then, what is the regex escape non-white space? So that's \s. Nothing. So there shouldn't be more. Are there an equivalent number of v? 744. Why? There should not be more UVs than there are vertices. That makes no sense. So I think what we need to do here is just do I think the easiest way is just to truncate the UV array, because I think that's what Unity will do anyway. So what we can do is vector2 array UV equals UV dot length greater equals UV dot length greater than. That is not what I meant to do. Basically, we can do UV dot array. So length greater than vertices dot length UV dot array 0 dot dot vertices dot length and otherwise we do just UV.to array. I think that should fix that. It's kind of a hacky fix, but I think it should work because that just truncates the UV, and anything else doesn't really make sense. Why is it still okay? So at least that time it didn't throw an exception. It truncated it, and it worked. But it's still not ideal. So 3 milliseconds. That's weird though. So both times it was 3 milliseconds compared to 25 and 29, which is again loads better. But it still doesn't make sense. Okay, you know what? I'll just take it. So I'll just take that while I'm ahead. So that's that. And I think the rest of it I'll probably just write on my own. So I'm probably gonna finish up here in a moment. So it has been great, and I will see you all later at some point. Maybe, probably.